In this video, we're going to use hyperbolas and applications. It says an engineer is designing a bearing with a groove having edges in the shape of a hyperbola. A coordinate system has been set up with each unit representing 1 millimeter. The closest the bottom of the groove, this is a key piece here, the bottom of the groove comes to the center of the bearing on the coordinate system is 19 millimeters. So they're talking about having a hyperbola that is set up like this, and that the distance here, so I'm just going to kind of point right in here, the distance from the center to this bottom part of the bearing is 19 millimeters. Okay, so that's actually our A value. If the groove has edges that follow the asymptotes y equals 3.5x and y equals negative 3.5x, find an equation for the hyperbola that can be used to model the edges of the groove. So if we have a hyperbola that's set up like this, we know two different things. We know that the asymptotes equation is y is equal to plus and minus a over b x. And we also know that our original equation we're trying to write is y squared over a squared minus x squared over b squared is equal to 1. They give us a already, so we can say that this is y squared over 19 squared minus x squared over b squared is equal to 1. They also tell us that our equation over here is y equals plus and minus 3.5x. So that tells us that a over b is equal to 3.5. Well, they already give us a, which is 19, so we can write this as 19 over b is equal to 3.5. If I multiply by b on each side, I get 19 equals 3.5b. If I divide by 3.5 on each side, I'm going to get b is equal to they say round to what? Round to the nearest hundredth. So we're going to use 5.43. 5.43 for b. So now I can write this as y squared over 19 squared minus x squared over 5.43 squared is equal to 1. And that's my equation for this bearing situation.